Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khurram, and in this channel I teach programming skills in Python, MATLAB or R programming. I also teach theoretical concepts as well as practical programming skills in data science, data analysis, statistical analysis or machine learning. So if you are a person who wants to learn Python, MATLAB or even R programming from beginning, or you are a person who wants to excel his career in data science, I request you to subscribe to my channel and hit the notification bell icon button. So as I stated that I will be producing a series of videos regarding statistical analysis in Python programming. So in today's lecture we are going to discuss about oversampling and undersampling, and we are going to exercise this concept with the help of Python programming. So let us briefly touch about the concept of oversampling. So oversampling involves increasing the representation of the minority class in the dataset by generating synthetic samples or replicating existing samples. It is used to address the class imbalance in datasets where one class is significantly underrepresented as compared to other. So how would your class be underrepresented in a dataset? It's quite easy. It will have less values as compared to the other class. So for example, one class will have that is underrepresented has a values of only 50 sample points, while the other class that is overrepresented has a sample quantity of like 1,000 or 10,000 values. So that's how you can actually judge what class is under represented or overrepresented. Okay, so in that case we have the concept of oversampling and undersampling, where oversampling involves increasing the representation of the minority class in the dataset. What it ultimately does, it actually helps us improve the performance of machine learning models by providing more balanced training datasets. Now you understand the concept of oversampling, and you can also see that by the help of this image where we have the original data where the one class is overrepresented, it has high number of samples, where another class is underrepresented as it has less number of samples. Now by synthetic sampling or by replicating the existing ones, we can actually come to the data set that has equal values of both or equal entities of both categories. Okay, so that is what we mean by oversampling. Now coming back to the undersampling. Undersampling involves reducing the representation of the majority class in the dataset by randomly removing samples. Okay, it is used in similar scenarios to balance the class distribution, but may lead to loss of information from the majority class. Okay, so you can see from that picture here that we have a data set where one class is underrepresented, the other class is overrepresented. What we actually do in undersampling, we actually reduce the class that is overrepresented from higher quantity of elements to the lower quantity of elements, where you actually balance the samples of other category. So that's what we mean by undersampling. So now you have a brief idea of about oversampling and undersampling and why we actually do it. We do it to actually enhance the performance of our machine learning model. So let's move on and practically exercise those concepts by the help of Python programming. So in order to do that, I'm going to import library. First I'm going to import the library NumPy by using this Python statement, import NumPy as np. Then I'm going to import the function or method resample from the library scikit-learn. I'm going to use this Python statement here from sklearn.utils import resample. Once I have imported my important library and also imported my method or function, let's move on and actually create the data for both class 1 and class 2. For in order to create a data, I'm going to use the function or normal by NumPy library, which what it will do, it will actually create a normal distribution or Gaussian distribution which had a specific mean, standard deviation. Okay, so in order to do that, first I'm going to declare or initialize a variable name like class 1 data, class 2 data. Then I'm going to assign its value by calling the NumPy method normal by using this Python statement here, np.random.normal. Then within those round brackets, I'm going to pass 3 input arguments through this method or function. The first one is actually loc is equal to 6, the second one is scale is equal to 2, and the last one is size. So the first one, loc is equal to 6, actually implies or specifies that we want a randomly distributed data set have a mean of 6. So the first option is actually for mean. Okay, loc is equal to 6. Then we have a second option which is scale is equal to 2. Once we have imported a library and important function, let's move on and actually creating the data for both class 1 and class 2. In order to create the data, we are going to use a randomly distributed Gaussian distribution that has a specific mean standard deviation. So we have like class 1. So for that purpose, I'm going to initialize a variable named class 1 underscore data and class 2 underscore data. After initializing a variable name, I'm going to assign some value to it by calling the numpy method normal. By using this Python statement, you can see np.random.normal in order to create a normal distribution. Then I'm passing 3 input arguments, as you can see in this Python statement here. The first one is log is equal to 6, the second one is scale is equal to 2, and the last one is actually size equal to 1000. So the first one, log is equal to 6, represents the mean of the distribution, that we want a randomly distributed data set that has a mean of 6. The second one is actually the scale, which represents the standard deviation of the distribution. In that case, we set it to 2. And the last one is actually the number of data points we actually want to generate it. In our case, we want 1000 data points to be generated by this Python statement, that normal distribution that has a mean of 6 and a standard deviation of 2. Now we will do the same thing for class 2, but in that case we want to underrepresent it. We want to have less quantity of that data, because then we are able to apply the concept of oversampling or undersampling. So in that case, we created another normal distribution that has a mean of 50, that has a standard deviation of 10, and that has a sample size of 100 only, as compared to the class 1 which has 1000 samples. So it implies that we have two classes that where the one class is underrepresented, as has only 100 points, and the other class is overrepresented, that has 1000 points. So let's move on and actually use this method resample from scikit-learn. So first of all, let's discuss. For this purpose, I'm going to initialize a variable name underscore sampled. Then I'm going to assign its value by calling this method or function resample. Then I'm passing 3 input arguments to this resample here. So the first one is actually the class 1 data. Okay, so this is the class 1 data. Okay, which as we are doing the undersampling, if by the name, as it implies by the variable name. So what we actually want to do, we actually want to reduce the size of the overrepresented class that has 1001, to bring it to the lower class to 1000. So basically the objective of this Python statement will be to actually reduce the size of from 1000 to 100. Okay, so that's the objective of this Python statement. So how we can actually do that? We are calling this method here resample. Then I'm passing the input argument 1000 data points, which ultimately I want to bring this value back to 100 value. Then I'm using this second input argument replace is equal to false, which implies that each element will be picked uniquely. Okay, so it will be picked uniquely, so there will be no replacement. Okay, and the last input argument is actually the size of the resampling, like how many data points you want to be resampled. So they declare the size of this undersample. So in that case, we want the length equal to the other class. So we are using this length method here and passing the input argument the other class, which actually calculates the size of other class, which in our case is 100. So that's how you reduce or undersample the data from 1000 to 100 by using this Python statement. And now we have let's move on and actually discuss about our sampling. What we will do, we will actually increase the size of class that is underrepresented, that has lower quantity 100, to the class that has a higher quantity data or our representative 100. So basically the objective of this Python statement is to bring category data that is class 1 data to 1000 samples, from 100 to 1000 samples. So how we can actually do that? First of all, we are going to pass the input argument class 2 here. First of all, I'm going to declare and initialize a variable name our sample. Then I'm going to create its value by calling this method resample. The first input argument I'm going to pass is class 2. where actually I'm going to reduce this quantity while I'm going to increase this quantity. The second input argument replace is equal to true. It specifies that a unique element can be sampled again and again, so which is again true in our case because we want to increase the values from 100 to 1000. So once we have done that, now we will bringing this smaller quantity to the larger quantity from 100 to 1000. So in that case we want to specify the size, okay, how much amount you want to actually increase this class data to. So in our case we want to increase it to the class that is our represented, that has a higher quantity. So in that case we are using this method, and sample is equal to len class 1 data. So now you get the idea how we actually undersample or oversample the classes. Once you have done that, all you have to do is actually to concatenate the classes with their sample data. For balanced data undersample, where we actually reduce the quantity to 100, then we are going to concatenate undersample data and class 2 data. Please keep that in mind. Both of these lists here, NP list has a size of 100 and 100. Okay, so they are being concatenated, and you also need to remember that this undersample has the category data of the class 1, that is undersample, that has been reduced, and then we have class 2 sample. Then for the balanced data oversample, where class 1 data has 1000 sample and our sample has also 1000 sample, but in that case our sample has been generated from class 2 data, and we have resampled again and again, increase its quantity from 100 to 1000. So that's how you can actually do it. Okay, so now once you have done that, now what you are going to do, we are just simply going to print the values out of it. So first of all, I am going to see what is actually the length of balanced data under, which is the data that has been obtained after undersampling. So once I run this block of code for you, now you can see that the length of this undersampled data is 200, and this is the sample data we actually get out of it. And if we want to calculate our sample data size, we are going to use this Python statement here, print function. Then we pass the first input argument, size of our sample data set, then the second input argument, which is actually the length of our sample data. So once I run this block of code for you, now you can see that our sample data set size is 20,000, because we are bringing the data that is underrepresentative, that has like 100 quantities to the equal to the data that has been our representative, like 1020. So when we bring that 100 to 1000, so we will have 1000 plus 1000, 2000 values, and that is the data also been printed. But don't get confused, like we only see like 6 values. You see this 3 dot notation, so it means the data had been truncated for printing. Okay, so it has 2000 values. So that's it for now, and for the concept of undersampling and oversampling by using Python programming. I hope this tutorial has been grateful to you, and if you have any questions regarding today's tutorial, feel free to write down your comments in the or feel free to write down your problems or questions in the comment section below. I will be happy to help you out. And as a reminder, I request you to subscribe to my channel and hit the notification bell icon button, because soon I will be posting more videos related to statistical analysis and especially regression analysis and Nova analysis and Python, which is helpful to you. So thank you for joining me, and I will catch you soon in the next.